Hello everyone, welcome to the session. I am C. Nitya, Assistant Professor, EC Department in R.M.K. College of Engineering and Technology. And I am handling the subject called Basics of Biomedical Instrumentation, and the subject code is OMD 551. Today we are going to see about the recording issues, that is a recording problem involved in the biopotential. So we will discuss in detail about this topic today. Recording problems. So we know that biopotential recording involves the measurement of extremely small potential only. So if we get that noise over here, our recording will get entirely different and it will distort the entire system. So the output voltage of an amplifier used to measure bioelectric event is not always an accurate representation of the event under examination. So the voltage that we are going to get is having a composed of both the voltage. One is desired voltage, that what we need, and the number of unwanted voltage, that is in the form of noise. So the desired voltage is called the signal. All unwanted voltage are referred to as a noise. Now we will see what are all the noise involved during the recording. First one is electrode and electrolyte noise. Second one is noise at the electrolyte and skin interface. Then motion artifact, electric and magnetic field interference, thermal noise, amplifier noise, noise from additional bioelectric events, and other noise sources. These are all the noise involved during the recording of biopotential. Now we will discuss about each topic in detail now. First one is electrode and electrolyte noise. First one is electrode and electrolyte noise. We know that electrode potentials can be measured between the interface of the electrode and electrolyte. So the stability of the potential of an electrode depends on the material that we are used and the way the electrodes will as prepared. The material that is mostly used for low noise recording of the biopotential, that is we already seen in the electrode two measurements of two electrodes. Here the silver chloride will be the best electrode to maintain the stability and also to improve the impedance. So next one is we are going to see noise at electrolyte skin interface. So during the measurement of only the noise signal produced by the skin will be the difficult task, as the EMG, that is electromyography signal, and other noise sources will always contaminate the recording. We know that only measuring of noise signal while recording the wanted signal will always contaminate the recording, and we can't able to predict the things which we want. So by increasing the diameter will reduce the excess noise, will give the solution to avoid the noise at electrolyte and skin interface. Next we are going to see motion artifact. We know that motion is nothing but a movement. Artifact is we can call it as in some type of distortion or misinterruption. Here we can particularly say that the non-polarized electrode will always create a variable noise, that we can call it as an artifact. Here the movement can cause change in the potential that are created when an electrode is applied to the skin. This artifact can be reduced by making the patient to be relaxed and using a high quality of electrodes. So this will give us a solution to avoid the motion artifact. Here the figures shows that a cross section of the electrode active surface is resist, that is it can be kept in a cavity in a plastic cup to reduce the motion artifact. Here the patient is kept at the cavity of the plastic cup. The skin electrolyte interface can cause artifact of about 400 to 600 microvolt when the electrode is moved parallel to the skin surface. So now we will see, if the electrode is moved perpendicular to the skin surface, the potential will changes of about 900 microvolt. So this artifact can be minimized by using equal off-cell potential and eye impedance. Next we will see electric and magnetic field interference. While measuring the recorded potential, always there is an electric, that is EMF, electric and magnetic field interference, which create a noise. Next one is thermal noise. We know that resistance. While we are doing our experiments in the lab also, we can see that after using or disconnecting the components from the breadboard, we can feel there is some heat produced on the resistor. So if we see here, every resistor will produce a certain amount of noise. The random movement of charged particle cause a thermal noise. So the value for the thermal noise will be given here, which Vth is equal to square root of 4k TBR, where k is a Boltzmann constant with a value, T is a temperature, B is a bandwidth of the voltage measuring device in hertz, where R is the resistance in ohms. Next we will see the amplifier noise. Amplifier noise. Amplifier is the most important components or a thing which is to be used in the biomedical instrumentation. If we see, the signal amplification performs the two important functions during the measurement. One will increase the resolution of the input signal and other one will increase the SNR, that is signal to noise ratio. For example, why we are using amplifier? The output of an electronic temperature sensor, we can take this as an example, which is probably in the millivolt range. So it is probably too small for the ADC, that is analog to digital converter, to process it directly. In such a case, we need to bring the voltage level up to that required by the ADC. So this is the way we are using an amplifier in the biomedical instrumentation during the measurement or recording. So the noise introduced by the amplifier can be modeled as two uncorrelated noise sources, Vn and In, and Zt is the electrode and electrolyte impedance. As the noise sources are independent, the total amount of noise from the amplifier is given in the below equation. Next one is noise from additional bioelectric events. Here they have given example for a cable movement. That we know, if we in general in hospitals and wherever we go, we can see there is a cable which is connected in the every devices. So the device movement, that is a cable movement, can cause an artifact, is it that is produces a strong magnetic field of MRI scans. So this can be avoided by, they have given a two ways to avoid this. So this can be avoided by amplifying the signal before it enters the cable, and this will reduce the artifact. Then various electrodes with amplifier circuits attached to reduce the noise. Next thing is other noise sources. There are some other noise sources which is produced due to the synthetic clothing, which can also produce as noise, and then RF, that is a radio frequency interference caused by the electrosurgical units. And this can be avoided by shielding, that is a proper shielding of this sources will reduces these problems. Adequate distance between this source of interference and the recording equipment, that is that we need to maintain some distance between the every recording equipments in order to avoid this noises. Then we will see about silver chloride electrodes. In the previous session That is in recording of two electrodes, we have seen that in order to maintain the high stability and the impedance, we need to use a silver chloride electrode. So it reduces the noise voltage and increases the stability. It stabilizes the half cell potential, so no movement artifacts are produced here. It reduces the low frequency electrode electrolyte impedance. This AGCl electrode uses a shielded cable to reduce the interference. Johnson noise, that is a random movement of charge carriers, or ohmic noise, that is ohmic component of the electrode impedance, occur in the microelectrodes. Using large area electrode and bioelectric recorder of high input impedance, the noise in the waveform is reduced. So this is all about the recording issues that we're going to have, and hope you all enjoyed the session. Thank you.